Assalamu alaikum and good evening all of you. Before starting anything, I would like to share a famous spiritual quote which I always use to amplify my abilities. It goes like Imam Ali Raza quote from his father Imam Musa Qasim. He quote from his father Imam Jafar Sadiq. He quote from his father Imam Muhammad Baqir. He quote from his father Imam Zainul Abidin. He quote from his father Imam Hussain. He quote from his father Maula Ali. He quote from the Holy Prophet Muhammad sallallahu alaihi wasallam. And he said, what faith is? Faith is knowing from your heart, expressing it through your tongue, and performing it with your organs. So whatever you do in life, faith is the basic necessity for everything. So the next step is the conversion of progesterone into 11-deoxycorticosterone. In this reaction, 21-hydroxylase enzyme is used. So this is the 21st position on which the change will be performed, and the name of the change is hydroxylase. Hydroxylase enzyme is meant to be performing hydroxylation, and the word hydroxylation means the addition or the final formation of a hydroxyl group. Now consider this carbon, it is a methyl simply with 3 hydrogens. So the hydrogen, as we have discussed earlier, in the hydroxylation of the hydrocarbons, hydrogen is already present and only oxidation is performed. So the reaction of oxidation is finally overall called hydroxylation because hydrogen is already present, and when oxygen is added, combinedly, collectively, it is known as hydroxylation because of the hydroxyl group. So simply oxidation reaction will take place on this carbon. So 3 hydrogens are already present and the 4th valency is occupied by this carbon to carbon single bond. So in order to add an oxygen, a hydrogen will be removed from this carbon. So when oxygen is added in the form of CH2O, the hydrogen that was removed for a temporary purpose is attached with the oxygen itself, and the final moiety appears as CH2OH. Consider just the addition of oxygen between these 3 hydrogens, CH2, oxygen and hydrogen, and the product is known as 11-deoxycorticosterone. The reason of the name of this structure is because it is a corticosterone structure in which on the 11th position, which is this position, an oxygen is absent. So in the next step there will be the addition of an oxygen on the 11th position, and this structure will be converted into corticosterone. Right now it is 11-deoxycorticosterone because this structure exactly represents corticosterone just on the 11th, with the exception of that just on the 11th position an oxygen is not present, so 11-deoxycorticosterone. So as we have discussed earlier that 11-deoxycorticosterone is a corticosterone on which on the 11th position an oxygen is not present. So this step will be the addition of oxygen, again oxidation. So the enzyme will be 11-beta hydroxylase, again hydroxylase because hydrogen is already present on the 11th carbon, which is not shown or exposed in the structure, but it is already present here. So simply an oxygen will be added. After the addition of oxygen, it will be represented as OH, that is a hydroxyl group. So at 11th position hydroxylation is performed, and after the addition of oxygen in corticosterone at 11th position, 11-deoxycorticosterone is finally converted into corticosterone. So this is the last step of the mineralocorticoid synthesis from steroids. In this step or in this reaction, the corticosterone will be converted into aldosterone. Two enzymes are used in this reaction, which are 18 hydroxylase and 18 hydroxy dehydrogenase. Now consider that these two enzymes are only present in the zona glomerulosa. So the aldosterone synthesis is only restricted to the zona glomerulosa. So the aldosterone synthesis is only restricted to mineralocorticoids because of the presence of these two enzymes only in the zona glomerulosa. So two reactions, for instance, will be performed. One is the hydroxylation at the 18th position of the structure. 18 hydroxylase is responsible for producing hydroxylation at the 18th position. Again, the addition of oxygen, and it will be finally represented as hydroxylation because of the presence of OH. The second is the 18 hydroxy dehydrogenase, means dehydrogenation at the hydroxy position of the 18th position. So in first step, an oxygen will be added at the 18th position, which is shown like this. At CH3, that is methyl, an oxygen is added, and this structure is represented as CH2OH. Now on this carbon, that is the 18th carbon, this is a intermediate structure I have drawn to explain. Consider this as 18th carbon. Now on the 18th carbon, a hydroxy group is present, and onto this hydroxy group dehydrogenation is to be performed. So the hydrogen will be removed from this position. So this is the dehydrogenation. Now this oxygen cannot survive, cannot remain stable with a single bond with this carbon, so it will force the carbon to remove one of its hydrogen in order to make a double bond with this oxygen. So after removing the hydrogen, this oxygen will be able to form a double bond with this carbon, so that the 4 valencies of carbon are satisfied and it can remain stable. So this is what have happened at the 18th position of the corticosterone, and finally after this reaction it is converted into aldosterone. So that's all about the mineralocorticoid synthesis.